Hello and welcome to this video on the weirdness that is water. Everyone has some idea of ice floating on water. This could be anything from your glass of water with ice cubes in it, or the Titanic sinking. This phenomena is just accepted as a fact of life, but have you ever realized just how unusual it is? The three states of matter are gas, liquid, and solid. Each of these is roughly progressively less dense. The density influences both the size and weight, or more accurately, represents these two and how they relate. With more density, the more likely an object is to sink. That applies no matter which state it is in, but more so between states of matter. This is why a rock sinks in water, but a duck does not. No wait, that's a different argument. Water deviates from this rule in a number of ways. This is sometimes called the triple point of water. The triple point of water is just above freezing, or 0.001 degrees Celsius. At this point, water exists as a solid, a liquid, and a gas at the same time in the same place. This is just the tip of the ways in which water is far weirder than you think. A solid amount of water weighs approximately 0.919 grams per cubic centimeter, and water as a liquid is 1 gram per cubic centimeter. When water is boiled, it reaches a density of 0.9584 grams a cubic centimeter. You can see how the bizarre transition between states doesn't match up with the expectation. While on the subject of expectations, solids and liquids, you would think that water follows the rule as a state of matter being most dense in a frozen state, even if the weight doesn't line up. If you think this, you would be very wrong. Water is in fact most dense at a temperature of 3.98 degrees Celsius, a temperature at which it is still a liquid, and very much not following the expectation of rules. This means water is most dense as a liquid, not a solid, but nowhere near getting to a solid yet either. We need to discuss another element of water, and that is the surface tension. Surface tension is how well things bond together at the liquid level, and how much you can effectively interfere with those bonds. Water as a chemical is really weird, primarily because it's made up of 1 oxygen and 2 hydrogens. The hydrogen of a water molecule will attract itself to the oxygen of another water molecule. This means the two begin interacting, and that short-lived hydrogen bond, amplified over many hundreds of times right throughout the water sample, creates a very high surface tension. This surface tension is enough that small insects can quite happily sit on the top of the water surface. This chemical relationship is actually something that brings us back to the very first point we made. Why it is that the water in different states has very different than anticipated densities. As you freeze water, it creates a number of large gaps. These are primarily filled with air. It turns it into something more like a sponge, rather than a solid crystal. The crystal formation is what we see in most other chemicals as they solidify. They become more and more dense. The incorporation of these voids within the ice itself is why ice, relative to its size, floats in its liquid counterpart. That's not the final strange and unusual thing about water. The most peculiar thing about water, in our opinion, is that hot water will freeze faster than cold water. Yes, something being hotter will mean it gets colder faster in the case of water. This is known as the Member effect, although spelling is slightly awkward. It was identified in 1963, or at least that's the date given to it. And the identification was simply this: that when you take something that's been heated, particularly water, and then try to cool it down, it will cool down much more quickly than cold water will. And we've discussed in some of our What Were They Thinking This Week videos as to why this might be and current research into it. remembering that the chemical structure of water can be quite odd. That's enough to confuse most people in one video. If you thought water was simply something that's wet, and feel free to debate that in the comments section, then you now know that there's far more to this otherwise ubiquitous liquid than you might realize. Thank you for watching this video. If you found it interesting, consider liking, sharing, and subscribing. Please post any comments, questions, or suggestions you might have below.